Hello! In this video I'm going to look at the magnetic field produced by passing an electric current through a piece of wire. So I've got myself a piece of copper wire, I've got a battery to provide the current, and I've got a compass to detect the direction of any magnetic field that's produced. Actually I've got two compasses, I've got a little one here as well. At the moment these are both pointing that way. Okay, that is north in this house. This one's pointing the same way as well. Just you can see it a bit better if I put a piece of paper underneath it. So they're both pointing in that sort of direction, which is north. So that's the default direction. So we're looking for a change from that really. So my battery is going to provide the current. The piece of wire is made of copper. Now copper is not magnetic, which means that it has no effect on the compass needle itself. So that's quite important. If this was made of steel, because I could use a steel wire or something, that would actually be magnetic and that would have an effect even if I wasn't passing a current. So copper wire, I'm going to pass a current through it. If you've watched my video on resistance, then you'll know that if I just connect it to the battery, it will just get very hot and smoke and probably melt. So instead of doing that, I'm going to put a light bulb in series as well to limit the current, and it will also help to show when there's a current flowing. So what I'm going to do is put my wire near to the compass and I'm going to connect it up and we'll see what effect it has. So that's the last connection. So let's make the connection and see what happens. Okay, a current is flowing and it's made the needle change direction. Disconnect the current and it changes. Okay, what will happen if I swap the connections around? Let's have a go. Well, the easiest way is actually just turn the wire the other way. So let's just turn my wire this way round. Okay, I've connected my wire the other way round. And the needle goes the other way. So it's definitely having an effect on the needle. So the wire, when it's got a current flowing through it, is causing a magnetic field and that's causing the magnet to move. So we want to find out what sort of shape the magnetic field is. So I'm going to move this over here. Now I have a hunch that the magnetic field is going to be in circles around the wire. So what I'm going to have to do to be able to measure that is put the wire on its end so that I can get the compass near to it and see whether the magnetic field is actually going around in circles. So what I'm going to have to do is find something like this, which I think used to have tomatoes in it. I'm going to make a little hole in the top, poke the wire through so that the wire can stand up vertically, and then I can rest this on the top and measure the direction of the magnetic field when I pass the current through it. So let's get that set up. There's my hole. I'm going to have to use a little bit of tape to stick my connections down to the board to make sure the wire will stand vertically, because the wire is tending to make it move. There we go. So now I have my connection, I have my wire sticking up through the tomato pot, and I can pass a current through it like that. Okay, and the light lights up, you can see that in the background. So I'm going to put my compass on here like this and see what happens. Okay, can you see that? Just about see that. Maybe I'll put a piece of white paper on the top as well, just to make sure that we can see the compass. Okay, I've made a hole in a piece of paper. I'm going to put that over the wire. This is just so that we can actually see the compass needle, because it's not very visible otherwise. Okay, how's that? Okay, we can just about see which way it's pointing. So it's starting off, the compass needle is pointing sort of that way, which is its normal position, and the current is going to pass through the wire. So let's see what happens. Current goes through the wire. Nothing seems to happen there. But there, it has twisted round a bit. Oh, there it's turned itself round completely. I think it was trying to do that here. I have a bit of a suspicion that my current is a little bit low, so it's not really having quite the effect on the compass that I would want. Right, so quick change of plan, I've used a bigger, well, not bigger, but more powerful light bulb, which produces much bigger current, because I don't think the current was quite big enough to actually deflect the needle properly. So now I've got my needle pointing that way north, which is its default. When I pass the current through, okay, the needle points all the way back this way. Okay, when I switch it off, it goes back to its normal direction again. Let's move it here. When I switch the current on, okay, the needle is now pointing that way. When I move the compass there and switch on, let's go so you can see the compass needle. It doesn't really move because it's already pointing in the right direction. And let's move it to here, and the compass needle points in that sort of direction. Whoops, that way. So it's kind of pointing around in each direction. So it's making a kind of a circle, very approximately, around like that. That's not drawn very well. And the compass needle was pointing that way. Let's change the direction of the current and see whether that makes a difference. So I'm going to disconnect the black wire and I'll reconnect the black wire, the red wire, to here. So I'm going to swap those over. Okay, so I've changed the direction of the current. It's a bit confusing because I've got the red wire connected to black now, but I've changed the direction of current. Let's see what happens to the needle. Okay, this time it's pointing that way. Let's move it round a little bit and connect again. It's pointing that way. Let's put it down to the bottom. And it's pointing this way. And let's put it round to the other side, and it should point that way, I think. Okay, yes, you can just about see it. It's pointing that way. Okay, so by changing the direction of the current, I've actually reversed the direction of the pattern. So let's move all this out of the way, and I will draw the kind of pattern that you should expect. Okay, so let's draw what we've got. I'm going to draw a perspective view of a piece of paper with a hole in the middle of it. There's my wire sticking down through the paper, and I connected it to a battery. And to start with, I connected the bottom, which was the black, to the negative of the battery, and I connected it through a light bulb. Let's put the light bulb in, and I connected that to the top. So in the first case, what I had electric current was passing from the battery through the light bulb, and it was going down through the cardboard or the paper. It was going down through the hole in the middle, and I was getting a circular pattern. So I was getting a magnetic field pattern, which was a circle. I could have done it if I had a strong enough current, because actually you need quite a strong current to make it deflect the little compass. I could have done it a bit further away, and I would have got another circle like that. Okay, and the way that I had it connected to start with the negative connected to the bottom from the battery and the positive connected to the top, meant that my circle was the arrow pointing that way round. Okay, so it was going this way. The magnetic field lines were pointing in that direction, circulating that way round. Now, often it's a kind of exam type question. You not only have to know that a piece of wire gives you a circular magnetic field around it, but you have to know which direction to put the arrows. And this is where there's a trick. You use your right hand and you make a sort of thumbs up like that, and this is used to work out the direction of the magnetic field lines, the direction of the arrows, if you know the direction of the current. So what you do is you take your thumb and you point that in the direction of the current flow in the wire, and in this case the current was flowing from the top to the bottom, so I had to make my thumb point from top to bottom. Then my fingers are curling in the direction that I have to draw on the arrows for the magnetic field. So with my thumb coming downwards, which is the same as the current, then my magnetic field lines are curling that way, so going round behind the wire and back to the front. So the arrows on the magnetic field lines go behind the wire and back to the front that way. When I turned the battery around, that reversed the direction of the current, so the current was going upwards and the field lines were pointing the other way because the compass deflected the other way. So I would turn my fingers this way round and that would have the curling arrows pointing round towards the front of the wire. So the arrows on the magnetic field lines would change. Okay, so that's the direction of a magnetic field caused by a single piece of wire.